Good morning everyone, my name is Jamie Hurst and today I'm going to take you on a journey I've found myself on over the last few weeks and months, which is going from zero to production in Azure. Azure is a cloud provider I've not used before. I'm mostly AWS trained, so going from zero all the way up to a production level application in Azure over a few weeks was quite an adventure. I'd like to take you along on that journey with me today. We're specifically going to be looking at doing this with Terraform, an absolutely fantastic infrastructure as code tool I have been using now for a couple of years. And we're going to see how you can get started extremely quickly and what tools there are, how Azure works, how Terraform works, and we're going to take a little bit of a journey and see how you can get both a stateless and stateful app running all along on the way. So, without further ado, let's get started. So, what is Azure? Azure is Microsoft's cloud offering. It's very similar to other cloud providers. It's slightly similar to AWS. It's slightly similar to Google Cloud Platform. The main difference with Azure is because it's Microsoft backed, a lot of it originally was very Windows specific. This has changed. This has changed from the last time I used it, which was probably about 3 or 4 years ago now. It's now a lot more. It's now a lot more Linux oriented. It's a lot more Linux friendly. It works very, very much in the same way that AWS works. If you've used AWS in the past, if you've used any other cloud provider, you'll recognise a lot of the changes. A lot of the terms are interchangeable with Azure and AWS. AWS has EC2 instances. Azure has virtual machines. AWS has EKS or Elastic Kubernetes services. Azure has AKS or Azure Kubernetes services. You can kind of see the theme here. The majority of it is transferable knowledge and skills between one and the other, but obviously each has its quirks. So moving from one cloud provider to another can be a bit of a challenge. Getting started on a new one though, getting started on Azure or taking Azure as your first cloud provider does offer quite a few advantages. Microsoft are very keen to get people on board their platform, and one of the things that they're doing at the moment, which I'll talk you through in a little bit, is that you actually get £150 worth of credit to explore the platform free for your first 30 days. That's something that's certainly been helpful for me getting to grips with this. So I'll talk you through how you go and sign up for an account and etc. later on. So the other tool we're going to be looking at today is Terraform. Terraform is by a company called HashiCorp. It's been around for quite a while now. It's written in Golang. It's a fantastic infrastructure as code tool which is designed to describe your infrastructure, everything that you're writing in either a cloud provider or elsewhere, in an easy language that's understandable by both humans and machines. It's deliberately not JSON. It's deliberately not anything that is a little bit too tricky for you to understand. It's deliberately not too syntactical. The idea behind it is that you should be able to get to grips with it very easily. There are multiple providers. Obviously it supports AWS, Azure, Google Cloud Platform, etc. But also it supports a lot of more independent cloud platforms, and obviously it supports bring your own estate. So if you want to run this on-prem or on anything else, you can. It's all very simple. It's all nice and easy. So we're going to go through some of the Terraform code I've written for this project today, and I'm going to show you exactly how it all fits together and how this can work in a production-like environment. Okay, so we have a lot to cover. The majority of the talk today is going to be a live demo. I want to talk you through everything as much as possible. I want to show you what I did rather than just talk about it. So without further ado, let's get started and we'll just jump straight into the code that I've written. So I'm going to do a little bit of an alt-tab switch here. So I've deliberately put everything together that I need today on GitHub. This is a public repository. You can come and find it. The link is at the end of the presentation, and I'll make sure this is shared around everyone as you're seeing it and as you're watching it. The idea behind it today is that I've deliberately built 2 applications using Terraform. One is a very, very simple stateless app that just uses a virtual machine inside of Azure. That one is about as simple as you can get from a cloud platform provider. But then alongside that, I've deliberately written a stateful application, one that uses a relational database, in this case MySQL, one that is a Dockerized application that we can run on Kubernetes and that we can expose through a load balancer inside of Azure. That'll teach you a little bit more about how Azure fits together in terms of networking, in terms of some of the security, how the services can link together. It's by no means a fully comprehensive, secure and completely practical production-like example, but it's a good starting point for you to get to grips with how you could progress one of your applications, especially one that was running on Kubernetes, into Azure at the moment without too much trouble. Okay, so as I explained earlier, if I jump onto Azure, I've already got my Azure account here. I've already signed up. Once again, I've got a link in the resources at the end. If you just Google Azure sign up, if you jump on and just search for it, or Bing it actually, if we're going to take a bit more of a Microsoft stance today, you will find that you can sign up to Azure for free, and you also get £150 worth of credit in your account. Now, as part of setting up and playing with some of the things that we've done today, I'm down to around £145. I'm still within my first 30 days, so it's great. It's a great way for me to get to grips with things. It's a great way for me to explore things. Now, as explained, Azure kind of works in the same sort of way that other cloud providers do. It's got things that if you've used AWS or Google Cloud Platform, you'll be pretty familiar with. It's got virtual networks, it's got a managed database service, it has virtual machines, it has blob storage accounts. That's kind of the general gist of it with Azure. One thing that Azure does a little bit differently than Amazon, in Amazon, most of you will, if you've used it before, you will tend to tag resources to group them together. Amazon tend to be more of a fan of kind of tagging things. In Azure, you get tags as well, but one thing that is slightly different is you get this overarching item called a resource group. Now, a resource group is designed to do exactly what it says on the tin. It groups several resources together. So within each of our applications today, we're going to use one resource group for each one. We're going to use one stateless and one stateful. Now, once you're inside of your Azure platform, you can go ahead and you can use the console, you can use the Azure portal, to do whatever you want to do. If you want to jump in and deploy a virtual machine, you can jump in and you can create a virtual machine. So if I go and do that just now, you can see I'm in my free trial subscription. I can use a resource group that's already been provided for me. So everyone has a Network Watcher resource group by default, but if you want to create a new one, you can create one called virtual machine or virtual machine test or something. We can do anything along those lines. I can create one here called virtual machine test, and we'll just create that. I can create my virtual machine. I can now call it Jamie's super simple VM. I want to probably create it in the UK South at the moment. I don't need any redundancy. I can choose which operating system I want. I can choose which size I want. I can deliberately kind of go against any of those, and I can go and pick one that's a little bit cheaper. So if I want to just pick the standard B1S, which is a little bit of a smaller instance, I can do that. And I can provide an SSH public key and everything, and I can decide exactly how I'm going to access my virtual machine. Now this is great. I can go through and I can create all of the infrastructure I need, everything that I want for my production-like application. I can set up for the majority inside of Azure portal. It exposes a lot of nice interfaces around how things work. It exposes a lot that you need in order to get started. It doesn't expose everything, and that can be part of the problem. It deliberately hides things to make it a little bit easier. But let's be honest, you don't really want to be going through a full interface like this. You don't want to traipse through a web interface in order to set up multiple virtual machines, multiple virtual networks, multiple clusters, and it's not exactly something that's repeatable, right? What about if you run into a problem? How do you want to go in and spend hours doing it all again? Do you want to show your colleagues how to do this? This is why we have infrastructure as code. This is why we have Terraform. What we want to do instead is we want to try building our infrastructure using Terraform. Now, one thing that Azure does that is very, very nice, that is one of my favorite things about it, is this cloud shell that it has. Now, up here you have access to what they call a cloud shell. This will spin up a VM in the cloud for you. When you go in, it will ask you to create a storage account. It will ask you to choose either Bash or PowerShell. Now, because I'm more of a Linux person, I've decided to choose Bash. And what I have here inside of my Azure portal is I have access to a virtual machine. I have access to a virtual workspace that I can use anywhere. I can spin this, I can log into my portal and I can spin this up on a different laptop. I'm not encumbered by needing tools installed on my machine. If I want to access Git, I have Git. If I want to access Terraform, I'll try doing it with actually a command on the end of it. If I want to access Terraform, I should have Terraform. There we go, I have Terraform as well. So, as I showed earlier, what I have here is I have my Azure Terraform examples repository. So what I'm going to do is I'm going to clone this into my workspace. So if I just copy that, git clone, paste that in there, I can clone this straight into my Cloud Shell. Now if I jump into that directory, all of my files are here. My stateless and my stateful applications are ready for me to install. So what I can do is we can start to run through what these individual infrastructure as code applications actually look like. Now, admittedly, looking at what it looks like inside of here, and kind of, I can list the files, I can cat them, I can show you, for example, what's inside of the outputs or what's inside of the variables and so forth. But we don't really want to look at it inside of, and we don't really want to work on it inside of a terminal like this. So what I can do is I can actually open a Visual Studio Code right inside of my Azure Cloud Shell. So now I can see the files that I have ready for me inside of my stateless application. So to talk you through a bit of a Terraform application, these are kind of the three files that you'll usually see inside of a Terraform application. They're pretty standard. Each of them has a TF extension for Terraform. So what we have is we have a variables file. The variables file stores the definitions of the variables you can set within your Terraform code. I've deliberately set this up and kind of described everything as I'm going here, so if you do want to follow along or you do want to look at the code later on, that's totally fine. I've deliberately parameterized a couple of the things that I want inside of my application. So for example, it's which region inside of Azure I want it to connect to, it's which host name I want to use, which prefix I want to use, things like this. So the idea is that each variable will usually have a default. So this way I can set up exactly what all of the default variables I want to have inside of my application. What I can do is I can create a new file called terraform.tfvars. Now, inside of terraform.tfvars, I can actually set different variables. With terraform.tfvars, let's say for example that I want my resource group value to be slightly different. So if I jump into my file here, I can actually check what the variable name is. So it's called resource group. So I'll copy that, pop it in here and say resource group is going to be called stateless resource group. Okay. I'm deliberately going to overwrite it. Okay, so now Terraform will automatically pick up this terraform.tfvars file when it works. It will automatically inject that variable in and it will use that instead of the default, which is perfect. Another file that we have is the outputs file. Outputs are all of the outputs that you want, informational or otherwise, about your actual infrastructure that it's created. So in this case, once my infrastructure is built, all I actually really care about is how to access my application. I'm deliberately building a very, very quick web server and I want to see how I actually get access to that. So it's going to output the URL and the public DNS for me. Okay. Finally, we've got the main.tf file. Now, this is the important one. It's the main file. This describes your infrastructure. So what I'm going to do is I'm going to run through everything that we're building as part of this stateless application. Okay. So first of all, inside of Terraform has different providers, as I explained at the start. We're using the Azure RM or Azure Resource Manager provider today. Okay. The first thing we're going to create is a resource group. Everything inside of Azure requires a resource group, so let's create one. We're using the location variable and the resource group variable that I just overwrote to actually declare what the location and the name of that resource group is. Once we have a resource group, we want a virtual network that our virtual machine can sit inside of. And we then want a subnet, which is a portion of our virtual network that we can host the virtual machine in. Again, this is using variables partially out of other resources that we've already created. So inside of the virtual network, I'm going to deliberately use the location and the name of the resource group that we created up here. You can see it's referencing Azure RM resource group, which is this, and then stateless, which is the name of that resource group or the individual identifier within Terraform. So I'm going to create my virtual network, I'm going to create my subnet, I'm then going to create a security group, probably quite familiar with those of you from AWS, to allow me to access parts of the VM. So specifically in this time, I want to be able to SSH into it, and I also want to be able to access it over HTTP. Then I will need a public IP address, so I can access it across the internet. This is going to use some more of the variables that we've set, including the host name and the resource group once again. I'm going to set up a network interface for my virtual machine so that I can pass the subnet and the public IP into there. And finally, I'm actually going to create the virtual machine itself. So inside of Portal, as you can probably remember, we were defining a few things about our virtual machine. We were defining the VM type or size. We could define the operating system. We could define how big the disk is. This is exactly what we're doing inside of here. We're specifying the name of our VM, we're specifying the network interface that we've just created, the resource group it's going to sit in, the size of the VM, and we're going to give it a username and password. We're going to tell it to install Ubuntu. This is what we have set up inside of our variables file, and we're going to tell it that it needs one disk and that it's going to be of the size that we need. We're then going to use a couple of different aspects of Terraform. We're going to use provisioners specifically. So I have a couple of scripts available to me inside of here. Inside of the bin folder, I have a very quick shell script that I wrote to initialize my blank Ubuntu box. What I'm going to do is I'm going to run apt-get update, and I'm going to run apt-install Apache 2. I'm going to install the Apache web server once it's set up, and I'm then going to set this to be my index.html file on my web server. Okay. Terraform will take this and it will automatically provision this onto the box. First of all, it's going to copy the file over. So it's going to deliberately copy setup.shell over into the home folder of the box itself. And it's then going to run it. It's going to make it executable and run that file. So it's going to set it up for me. It means that I don't need to do anything else. I can copy a file over and I can remotely execute it using these commands that I'm going to run right here. And that's it. That's the end of my Terraform file. Okay? That's all I need to do. That's all it's going to do. So, how do we run it? What do we actually need to do? In order to run our Terraform file, there are a couple of commands that you need to run. So, first of all, we need to initialize our Terraform environment. We've told it that it needs the Azure RM provider, so what we're going to do is actually download and initialize that provider by running Terraform init. Terraform init will go off and check what backend it's using, it will check any of the plugins it requires, and it will download them. And as you can see, my Terraform has now been successfully initialized. What I can do now is I can plan what my environment's actually going to look like. This is a bit of a dry run. This is what Terraform's going to do without actually doing it. So if I run Terraform plan, it's going to jump across and it's going to connect automatically to Azure. Now I don't need to specify anything in terms of the Azure command line or any of my profile information or anything. Because I'm inside of the Cloud Shell, Terraform just can automatically connect up to my Azure account. It's telling me it's actually going to add 8 resources. So it's going to tell me exactly what everything's going to look like. It's deliberately put pluses against them. In order to run it, now that I know what it's going to look like, let's give it a try. I'm going to run Terraform apply, and I'm going to see exactly what the outcome of running my application inside of Terraform is going to be. Terraform apply will go off and do the same thing that plan does. It will go off and calculate what the differences between the current state, the current infrastructure are, and what it actually is going to do, what it's going to go off and run. Once Terraform apply starts, it will then start to actually build and run the infrastructure in line. So we'll just wait for it to jump across and actually start here. Okay, and now all I need to do is type yes, and then I'm good to go. And it starts running, that's it. It starts creating things inside of Azure. So you can see straight away it's creating my resource group, and it's going to go ahead and it's going to create everything that I need, everything that I've told it to create inside of the stateless application. Okay, so what I can do while that's creating is I can close my editor here, so I don't need that open anymore, and I can drop my window ever so slightly. What we can do is if I jump into all resources, I just make my terminal ever so slightly smaller, you can see what it's doing. So you can see that it's using the name example to create everything because that's what I'd asked it to do at the start. You can see that it's creating all of the resources that I've specified inside of Terraform. I have my network interface, I have my public IP, I have my virtual machine and my virtual network. As you can see, Terraform provides you with output as you're running through as to what it's doing. Right now it's still creating my virtual machine. It sometimes can take a few minutes to do certain actions depending on what it has to do. Obviously the virtual machine needs both spinning up and then provisioning because we need to copy across our file and then run it in order to set up our Apache application. Now in terms of provisioners, there we go, it's actually provisioning it from the file now, and it's then going to execute that command. In terms of provisioners, Terraform can work with all sorts of different ones. If you've used anything along the lines of Puppet or Chef or even Ansible, Terraform works with those as well. I've used Terraform quite extensively with Ansible in the past, and the two behave quite nicely together if you need to provision any resources or you need to configure machines that you've set up in this way. So we just need to wait for Terraform to finish provisioning from a remote execution point of view. At the moment on the box it will be updating the Apache package and installing it and then copying everything across. Once Terraform is finished, it will then tell us the results of everything that it's done, and more specifically it's going to tell us the output. So it's going to tell us it's created 8 new resources, and it's going to tell us actually here's what I've created, this is the URL of what I've provisioned. Now if I click on it right now, my application's there, it's running in the cloud. My mighty Morphin Power Rangers live at the moment. As I said, it was a very simple stateless application. I make no bounds about trying to do anything a little bit more complicated on the first run that I run through. Okay, so you can see, if I minimize this ever so slightly, if I jump into example web, here's my virtual machine. It's running Linux. It's a standard B1S. There's the public IP that we provisioned. There's the DNS name that it's set to. I can see the disks, so I can view everything that I've done as part of this inside of Terraform. Now if I jump back onto this, you'll see that what we have inside of the directory now is we have a new file called terraform.tfstate. This is where Terraform stores its statefulness. If I now run Terraform plan again, without making any changes to my infrastructure, it's going to go through and it's going to realise that actually it doesn't need to do anything. The infrastructure is completely up to date and there's no need to change anything. So Terraform is stateful. This is the whole point. You can make incremental changes to your application and then you can change it, run Terraform, and it will update your application in the cloud inside Azure. So a stateless application, that's quite easy. Okay, we can do a little simple deployment like that. That's not too tricky, right? How about if we wanted to tackle something that's a little bit more full on? This is an example that people tend to use, and I've noticed this run around a lot, deploying a stateless application in the cloud. That's great, I can build a VM, no problem. What we really want to do is build something that's a little bit more robust, a little bit more tricky, okay? So what we're going to do is we're going to deliberately look at a different file. So my stateful application, this one's a little bit different. This one is a fully Kubernetes cluster using AKS, or the Azure Kubernetes cluster. We have a MySQL database. We need to be able to connect between both of those. We need to be able to then deploy our stateful application on top of Kubernetes, and we need to provide access to it through an ingress. And we're going to do all of that automatically in Terraform. So I just need to do the same thing that I did on my other infrastructure, and I just run Terraform apply, and that's all it is. Now, off camera, I'm just going to jump on right now and deliberately delete my old stateless application, so I can start just from scratch on my stateless one. So let me just very quickly run you through my file. I know that this is definitely one that you're going to want to do off camera as well, but just to give you a little bit of a flavour. So We're using a random provider to generate our random MySQL password. We're going to use a Kubernetes provider and a Helm one to deploy some resources on top of the Kubernetes cluster that we're planning to build. Again, we're going to create a virtual network and a subnet and a security group. We're going to associate it in the same way we did before, and we're going to create an Azure public IP. So far, pretty much the same. This is where things start to get a little bit interesting. I'm going to create a random MySQL password, and I'm going to spin up an Azure RM MySQL server. Okay, it's just a simple little MySQL cluster, nothing too tricky, but I want to pass my password in so that I don't need to know what it is. I don't really need to know what the MySQL password is for this right now. I just want to be able to push it and inject it into my Kubernetes cluster, into my application so that it knows how to connect. I'm going to create my stateful database inside of my MySQL server. I'm then going to set up the firewall rules to allow access to Azure, and I'm going to spin up my Kubernetes cluster. My Kubernetes cluster is going to have 2 nodes, just 2 nodes to make it easy for now, and it's going to provide up to 30 pods, nothing too extravagant. I'm then going to make sure that my Helm and Kubernetes deployments are working, so I'm going to deploy my ingress controller, my standard Nginx ingress controller, and I'm going to deploy my stateful application as a deployment inside of Kubernetes. This is a little different because it's not a YAML file. You can include a YAML file instead, and you can then just have it as an external file, but I've decided to write this in the more Terraform way so you can see how you would do it inside of Terraform. And I'm then going to deploy my Kubernetes service and finally my Kubernetes ingress. Haven't bothered with SSL this time. I could have set up a Let's Encrypt service and everything alongside of this, but for now I just wanted to keep it relatively simple. So, in this, it's going to work in exactly the same way. I'm going to run Terraform init to make sure that I have all of the providers that I need, because right now I need random Kubernetes, Helm and Azure RM, so I need to make sure I have all of those. I'm then going to just go straight ahead and run Terraform apply. It's going to go off and calculate exactly what it needs in order to run this. Okay, now as a caveat, just to be clear, I've deliberately destroyed all of the old infrastructure that I created on the stateless application. I don't want it to interfere, and just to be on the safe side, I want to make sure that that's not something that's going to happen. So, as far as we're all concerned, this is a brand new Azure account that I'm deploying my stateful application into here. So, I run Terraform apply in the same way that I would have run it before. I just want to go straight to the apply this time. There's no need for us to plan. As you can see, this time it's going to create 16 new resources. So, let's go ahead and create those. Now, I'm going to jump straight to the end to make sure that you can see what it's created, as you do want to sit here and watch. It can take up to around 10 minutes for all of these resources to create this time. So I'll just jump up to the end. Alright, so what have we got then? So, let me just check it first. Alright, so everything's built. It's taken around 10 minutes or so. We've now got our full cluster, our ingress, everything that we need. If I click on my link here to go to stateful, it loads up a stateful application. I can create a new Power Ranger, such as a green one, and save it. I can delete the white Power Ranger, I can delete the red Power Ranger, I can edit the black one, I can edit the blue one and call it even better blue or something along those lines, and that will save. So you can see I've got a fully stateful application. If I copy that, open the link somewhere else, it retrieves the data again. This has been stored in the MySQL database. So, more importantly than that, what have we actually got inside of our Terraform cluster? What have we done here? So, to give you a bit of a flavour of how the Kubernetes stuff works inside of AKS, what I can do is I can actually use the Azure command line to get the credentials I need inside of my stateful resource group. My cluster is actually called stateful AKS. So what I have here is I have a set of Kubernetes credentials. I have access to kube control from within my cloud shell. I can get the pods. You can see that I'm running an Nginx ingress controller, a stateful application. I get some logs on here. You can see that it's actually listening on port 3000 and it's initialized the database. I can see, fully access my ingress from here. I can check my ingresses and I can check my services. Everything is exactly what you'd expect, and you can see it's mapped onto the external IP via the Azure load balancer. That's created a full Kubernetes cluster just from that Terraform file that I've created there. Now, you will need to explore this at your own leisure in order to get a bit of a flavour about what you can do. So, what I want to leave you with are a few links. Please head to Azure if you want to give it a try and sign up. As I say, you get £150 free. There's no reason why not. For 30 days, you may as well give it a bit of a try and see how it works for you. Terraform, please give Terraform a go if you haven't already. You can see how easy it is to get started with it. I have a good set of examples here. Here's my link to my GitHub repository. Please feel free to fork it or change bits and pieces. There are plenty more examples out there as well. Thank you very, very much for listening to me today, and I hope this was a little bit of help to you. Thank you.